Hello, my name is Peter Todd and my lab partner is Andrew Mickey. This is our video report for Lab 7 Michelson Interferometer 2 in OPTI380A at the University of Arizona Wyand College of Optical Sciences. This lab continues from our last week's experiment with the Michelson interferometer as described in the diagram in the bottom right. This time we're using it for precise optical measurements, first to calibrate mirror motion using a helium neon laser, then to measure the wavelength of different light sources, and finally to determine the wavelength separation of the two peaks within the spectral emission of the sodium lamp used in lab.
So for this part of the lab, we had one student adjust the micrometer while the other student counted, and as we moved the micrometer, the fringes changed, and so one person counted them, and one person adjusted the micrometer, and they stopped once we reached 100 fringes, and then we counted the number of fine units that we had rotated, divided by 100, and then we divided the wavelength of the laser by that to find the length of the fine unit. For part B of the lab, we did a very similar procedure, where we had our source and our micrometer, and we moved our micrometer and counted fringes. For this, we repeated the setup with the laser and calculated the wavelength based on our configuration factor we got. Then we replaced it with this sodium lamp, which we counted 50 fringes, found the number of units, and then used our configuration factor to find the wavelength for the sodium source and for the mercury source.
So in this part of the lab, we started with our setup from part B with the sodium lamp and our interferometer. In this part, we adjusted our micrometer until we found 2 points either side of the fringes, called the null points, where the fringes were the least defined and the least visible. We then took those to two source distances, to find the distance between the two primary wavelengths of the light in the sodium. And here's a video of the Haldringer's fringes we observed from the sodium lamp. The chromatic colors you saw at the beginning were likely caused by thin film interference introduced by fingerprints on the diffuser between the interferometer and the source. You can also see at the end that the fringes virtually disappeared. This is one of the null points that we measured in lab. In conclusion, our measurements using the Michelson interferometer showed very good accuracy. The maximum error among our wavelength measurements was only 6.17%, demonstrating that our calibration and fringe counting methods were reliable despite our doubts. This experiment confirmed that the precision and versatility of the Michelson interferometer for optical experiments. And it was fun. Thanks for watching.